Hi, everybody. We have made it to the end of Unit 2. We're on our very last little topic, which is really just an extension of what we've already been doing. We are going to talk about solutions to systems of linear inequalities in two variables and look at how to graph to find those solutions. So, a solution to a system of linear inequalities is a pair that makes both inequalities true, or any pair of values that simultaneously meets both constraints in the situation. This should sound very much like a system of equations solution. We're talking about meets both constraints, therefore is a solution to both inequalities in the system. So, let's suppose that we have two numbers, x and y, and there are two things that we know about them. So the value of one is more than double the value of the other. So y is greater than 2 times x. And also that x plus y is less than 10. So we can represent these constraints with a system of inequalities, which you see over there on the right side of your screen. There's some different possible pairs of numbers that could meet the first constraint. So for example, 1 and 3 are possible values for x and y. 4 and 9 are possible values for x and y. And we can say the same thing about the second constraint. So for example, 1 and 3 are solutions, or 2.4 and 7.5 are solutions. This pair x equals 1 and y equals 3 meets both constraints, so we can say that it's a solution to the system. Now, thinking about that inequalities have a solution that's a range of values, that solution set, we are going to think about, well, how do we represent that? And so, for example, this pair x equals 4 and y equals 9 meets the first constraint, but not the second. And we know that graphing is a really nice way to show all the possible solutions to an inequality in a really easy to see way. So we would start by graphing the region, the solution region for each inequality. So you can say, or see here on the left, we have our first inequality, and on the right, we have our second. And I'm going to jump over to Desmos to show you that too. So here you can see I have graphed my first inequality, and I'm going to turn that off for right now. And here is my second. So I have solutions for both the first and the second inequality here on the graph. So now, because we're looking for a pair of numbers that meets both constraints or makes both inequalities true at the same time, we want to find points that are in the solution regions of both graphs. And so to do that, we can graph the inequalities on the same coordinate plane. So you just saw them graphed individually. And here you can see what it looks like if I graph both on the same coordinate plane. And the solution set to this system of inequalities is represented by this region where the two graphs overlap. So you can see shaded in blue, that's my solution region for one inequality. And you can see this shaded with these lines here. That's the solution region for the second inequality. But this place where you see both blue and the lines, those are solutions to both inequalities. And so if we go over to Desmos, and I turn both of them on, that region that's purple, that represents the region where you have solutions to both of your inequalities. Whereas the region that is red or blue, that is a solution to one of my two inequalities. And the region that's white over here, those are not solutions to either inequality. And so this should now be enough information for you to work on the Google Doc assignment and Flipgrid. And this covers all of the rest of Unit 2.